Als Festredner haben wir heute unseren Dauerreferenten, glücklicherweise darf ich das sagen, Professor James Oschman aus Amerika. Und ich kann mir einen gewissen Stolz nicht verkneifen. Ich habe Oschman im Jahre 2001 kennengelernt, als ihn hier noch überhaupt niemand kannte. Ich habe ihn auf einem Kongress in Boulder kennengelernt und er hatte gerade sein erstes Buch herausgegeben, das auch in Amerika noch damals gar nicht groß bekannt war. Und ich fand das so spannend und ich fand ihn als Person und als Referenten so überzeugend, dass ich ihn damals eingeladen habe. Inzwischen ist das ein fest etabliertes Verhältnis, was wir mit ihm haben, und wir freuen uns, denn mittlerweile ist Professor Oschman weltweit ein so gesuchter Referent, dass es kaum noch möglich ist, wenn man nicht früh genug anfängt, mit bei ihm Zeiten zu bekommen. Und wir könnten ihn eigentlich sonst auch gar nicht bezahlen. Er hat mittlerweile den Spitznamen Mr. Energy Medicine und unter diesem Namen ist er, wie gesagt, mittlerweile weltweit bekannt. Professor Oschman wird einen Vortrag halten über sein zentrales Thema auf Englisch. Da braucht niemand zu erschrecken. Er spricht ein so klares Englisch, dass jeder ihn versteht. Ich habe noch nie gehört, dass jemand Probleme gehabt hat, ihn zu verstehen. Sein Vortrag heißt Energetics of the Living Matrix, auf Englisch, wie gesagt. Jim, please.
I'm all hooked up.
Thank you.
Half hour. How nice to see you. Greetings. Here we are. Thank you, Hendrik, and all of your helpers and colleagues at DGEIM. Thank all of you for coming. This is a very nice experience for me. My website, energyresearch.us. I've got it right here.
Do you have a better one?
Yeah, thank you. Energy medicine includes a lot of hands-on and hands-off therapeutic methods and techniques, as well as devices. And this is very exciting. Exciting things are happening in the world of the therapies and in the world of devices. And I've only shown a few of the devices. There are many others that are on display here today. It's very interesting. It's a very interesting and rich field, this field of energy medicine. It's very exciting. I now travel all over the world as energy medicine is emerging in many countries around the world as a preferred technique or set of techniques for the public who's interested in devices and techniques that stimulate healing without side effects or with minimal side effects. I need to introduce you to my assistant. This is my helper, Tweety Bird, who is very honest and will show up and say baloney if I say something that's wrong. And just to make sure that you understand the significance of this, here comes that phony baloney now. So baloney is, in English, it means nonsense. And here is someone eating some baloney. So just so you know what baloney is. A review of the living matrix concept. The idea and discovery that the genetic material, the DNA, in the nucleus is embedded in a matrix, a nuclear matrix, which is embedded in a cytoskeleton, a cellular matrix, which is connected to an extracellular matrix, which is connected to the connective tissue. This is the idea of the living matrix. The connective tissue, and here we're talking about tendons, ligaments, the myofascia, cartilage, bones, the superficial fascia, the tissues that make up most of the body. This is the largest organ in the body, is the living matrix. It is the organ that makes up all of the other organs. All of the other organs are made of this system, and it's continuous. The cells in these different tissues form a continuous system. This information has been around for a long time. This is from 1984 and shows the skin. This is a skin cell which has a nucleus and it has fibers inside of it, and these fibers cross these hemidesmosomes to these anchoring filaments and then connect to the collagenous bundles in the connective tissue. So anywhere you touch the body or put energy into the body, you are touching this continuous system. Research at Harvard in the laboratory of Donald Ingber has shown that the cytoskeleton behaves like a tensegrity system. It has viscous properties. I emphasize this because the conventional view of the cell is wrong. And this research, where they used particles that attach to the cell surface, these are magnetic particles. And in a magnetic field, these particles will twist. And then when you turn off the magnetic field, they relax. And you can measure how long it takes them to relax, and you can measure the viscosity of the cytoskeleton. So this is the cell surface, and this is cytoskeleton. It behaves like a tensegrity system. Here is a fundamental question in biology and in medicine. How do we account for the unitary nature of a living organism, the way it responds as a whole to any stimulus, as if every part of it knew what every other part is doing? That's a good question. The same fellow, Roger Taylor, says this: life has this holistic property at any scale, from an amoeba to an elephant, and whether or not it has a nervous system. So single-celled animals have this characteristic. The problem with holistic thinking is that it's a multidisciplinary affair. People are too lazy to do this. It's a lot of work. You have to learn about all of the different areas of biomedicine and science to understand holism. And we're very comfortable in our little taking things apart and studying one piece at a time. Holism requires us to really open our eyes and look at the whole system. So that's the problem. This fellow climbs the mountain because it's there, and this fellow just doesn't feel like it. And here's another one. Lazy. Physics has a very good definition. In physics, energy is defined as the ability to do work. And this woman is not doing her work. So that's work. But that's okay. I'm going to tell you the key discovery that made all of this living matrix come together. And the discovery was reported in 1971 in 3 papers by Mark Brecher from Cambridge, the Medical Research Council laboratory, a famous laboratory where lots of great work has been done. And Brecher was studying the cell membrane of the red blood cell using radioactive tracers. And he asked, is the protein stuck on the outer side of the membrane? Does it extend into the membrane? Does it extend deep into the membrane? Or maybe it goes all the way across. And what he discovered was that it goes all the way across. And these are his classic papers published in the Journal of Molecular Biology and in Nature describing this. This created a big change in the way we look at cells. And it was discovered that he was right, and that, in fact, many proteins go back and forth across the cell surface many times. This is a single protein that crosses the cell membrane 7 times. And this happens often in receptor cells, which I'll have more to say about. The textbooks are always wrong about this. There are no textbooks that have this story right, except for mine. Read my book. They show that the cell has a solution in it, and out here is the connective tissue, and this is baloney. This is not correct. Not only is this wrong, but it really confuses us. How can medicine progress, especially medicine based on cell biology and biochemistry? How can cellular pathology, which has been with us for hundreds of years, how can it function if our image of the cell is incorrect? Virchow's cellular pathology is a dominant medical model, and the cell image is wrong. This was a very profound discovery, that there are these molecules that extend across the cell surface and connect the cell interior with the extracellular matrix, and this is a hardwired system. The extracellular matrix is hardwired to the cytoskeleton and the nuclear matrix, and these are mechanical and energetic and electronic linkages. It's like the circuit diagram of the body. The extracellular matrix is continuous with tendons, ligaments, myofascia, cartilage, bone, superficial fascia. I said that before, I'll say it again. This is a continuous system. Here's how I got introduced to this by Albert Szent-Györgyi. He introduced me to the energetics of life. He's famous for the synthesis of vitamin C and the discovery of actomyosin. And also now he's being recognized for his pioneering work on electronic biology. He said this: life is too rapid and subtle to be explained by slow-moving chemical reactions and nerve impulses. He got this idea from observing his cat. He took his cat on a camping trip to England. And the cat, one morning he watched from his tent as the cat went out into the grass and saw a snake and went boing, straight up in the air. And he thought about that for a long time. I've wanted to do that myself from time to time. Here is a quote from an interview with one of his colleagues, Ron Pethig. The cat just suddenly shot up in the air because it had seen a snake. And he, Prof was our nickname for Albert Szent-Györgyi, Prof said there was no way that the whole reaction, the cat, everything in the cat would turn on at once. There was no way that it could be related to anything mechanical. It had to be submolecular, electronic. There's another communication system in the body. He said, the proteins are the stage upon which the drama of life unfolds. The actors can be none other than small and highly mobile units, such as electrons and protons. I would say that the living matrix is the stage. This whole system that forms all of the systems of the body is the stage upon which the drama of life unfolds. And the actors are electrons, and some of them are electrons that are present in double bonds in the protein backbone, and they are delocalized. That is, they don't have to stay with that bond. They're free to move throughout the organism. Here is an example of a biochemical process, glycolysis. It's a series of enzymes that convert glucose to pyruvate, 10 enzymatic steps. And this is the conventional way of viewing it. Here are the enzymes floating around in the cell. This is, by the way, baloney. It's not like this. So here are the 10 enzymes, and here comes glucose diffusing through the cell until it encounters the first enzyme where it's phosphorylated to glucose 6-phosphate, and then that molecule diffuses around until it encounters the second enzyme, and so on and so on. This is the conventional biochemical view of cellular biochemistry. If this were true, if this were accurate, it would take 10,000 years for you to digest your breakfast. This is clearly impossible. It can't be like this. So this is what Albert Szent-Györgyi was talking about when he said life is too rapid and subtle to be explained by slow-moving, diffusion-limited reactions. And it took me a day to make this slide, so I copyrighted it. It took all day. And remember, life is too rapid and subtle to be explained by slow-moving chemical reactions and nerve impulses. And now let's take a look at nerve impulses. This is the work of Joey Jones at the University of California in Irvine, who discovered that if you stimulate acupuncture points on the bladder meridian, on the toe, these are vision points, points that have been used for thousands of years to correct vision problems. This, of course, makes no sense, that you would treat the eyes by putting an acupuncture needle in the toe. That makes no sense. What he and his colleagues discovered is that when you needle these points, the visual cortex lights up in functional magnetic resonance imaging. You can see the nerve cells in the visual cortex firing. And this was a fantastic demonstration that acupuncture interacts with the brain. Needle in the toe affects the brain. He went on to stimulate these points with ultrasound. You don't have to touch the point. You just beam a little bit of ultrasound in there, and he discovered that the signal gets from the toe to the brain extremely rapidly. With sonopuncture, with ultrasound, the cortex begins to light up in 7 microseconds. This is the fastest known biological process. In other words, the matrix is a very high-speed system. He discovered that there are actually 3 communication systems. One is the very fast one, then there's one at neural velocity, meters per second, that's prevented with nerve inhibitors. And then there's a slow wave corresponding to some kinds of qi. So life is too rapid and subtle to be explained by slow-moving chemical reactions and nerve impulses. There's another system in the body that is very fast. This is a more realistic view of metabolic processes like glycolysis. These are called metabolons. They've been known about for a long time. It's as though the enzymatic system is set up like an assembly line in an automobile factory. The glucose comes in, interacts with the first enzyme, and pyruvate pops off the other end. And this is called metabolic channeling. The product of the reaction is directly transferred from enzyme to enzyme in sequence without having an opportunity to diffuse away. And this makes it very, very fast. It is extremely fast. It's like this. It's as fast as a rifle bullet. As fast as a rifle bullet. 1,000 meters per second. That's how fast these enzymatic processes are. That's an extraordinary statement. It comes from the 1999 Nobel lecture of Ahmed Zeewal, who developed femtosecond spectroscopy, as fast as a rifle bullet. And the enzymatic activity is affected by things going on in the matrix, tensions, voltages, currents in the matrix. This is a basis for hands-on methods, which introduce voltages into the matrix, and it's a basis for devices such as the OnDemand and many of these devices that are on display here today that interact electrically with the matrix. This is a book that has just been reissued. This is Pischinger's work, almost 40 years of very fine German research and clinical practice related to the matrix. The extracellular matrix and ground regulation, this is a new translation into English. Professor Heine has put a lot into it. I hope it gets translated back to German so that you can all enjoy it. I wrote the foreword for it. I think it's very valuable for any school of therapy to know about this work. So the matrix is made of specific things: collagen, the ground substance, the cytoskeleton, the microfilaments, microtubules, microtrabeculae, actin and myosin. The nucleus has its proteins, the histones, and the integrins, the molecules that connect it all together to make it a continuous system. This concept of the living matrix has become valuable in many schools of therapeutics. And to find out about that, you can just look up living matrix plus Oschman on Google, and I did that this morning. There are 708 web pages that talk about this. This is just to give you an idea of the interest in this concept. Yeah. I want to say a few things about energy and perception. The way we perceive our world, our inner world and our outer world, depend completely on our ability to sense and mobilize energy. So we're talking about heat, light, sound, smell, taste, gravity, touch, and the textbook description of the process by which we sense information in the environment, pass it on through the sensory nervous system to the brain, and then we decide if we want to do something. We send signals to the muscles. This is the textbook story. And the sensors are all ciliated. They have these remarkable structures called cilia. For example, we smell with these hair-like appendages in the olfactory epithelium. And what all of these receptors have in common is this incredible organelle called the cilium. And I emphasize this because this is the first place where energy interacts with us, whether it's smell or vision or whatever. And the eye can detect a single photon, and this very interesting piece of work, Camelot et al. From 2000, about the acoustic system, about the sensation of sound. Auditory sensitivity is provided by self-tuned critical oscillations of hair cells. So these are the hair cells in the ear that are enabling you to hear my voice, and they vibrate. You can actually detect sound coming out of the ear if you put a microphone next to the ear. And sensory systems have to be nonlinear. They have to cope with signals that are very weak and signals that are very strong. And they have to be nonlinear, otherwise very intense sounds would overwhelm the nervous system, like this. Sensory systems must be highly nonlinear, otherwise loud sounds would overwhelm the nervous system. And the nonlinearity is well documented by a lot of research, including that of Prigogine, who got the Nobel Prize for nonlinear phenomena in biology. So these people introduced this as a general concept of sensation. Self-tuned criticality. In other words, the hair cells are vibrating, and the rate at which they're vibrating is adjustable so that you can adjust their sensitivity. And this probably applies to all the sensory systems. By controlling the hair bundle's propensity to oscillate, a feedback system automatically maintains the sensation in the operating regime where it's most sensitive, even if the sound is high or low. Bacteria and protozoa can sense and respond to their environments. They don't have nervous systems. Here is an interesting concept that you can think about. This comes from a paper in 1973. Movement is sensation in reverse. Sensation is movement in reverse. And he's referring to, for example, the flagellum in a bacterium. Sensory information interacts with the flagellum and is propagated along the flagellum into the cell, and if the cell decides to move, it sends a signal, a conformation wave out along the flagellum, which causes it to move. So sensation and movement are related to each other at this simple level, and this may apply to living organisms. Well, neuroscientists study receptors. They put electrodes in a sensory nerve, and they measure the potential across the nerve. And here's what they find. If you record the potential in the sensory nerve, you find it's varying, and when there's a tiny signal, there are subthreshold potentials. They're not strong enough to trigger an action potential in the nerve. If the signal is strong enough, it triggers action potentials that are conducted through the nerve. This is standard neuroscience. I ask the question, what happens to the information in these subtle signals that are not registered by the nervous system? Are they lost to the organism? As a biologist, I know that organisms are very efficient. And so I thought a long time about this, and I decided for sure these signals are registered. So what I think happens is the following. All of the energies are analog. That is, they go from very low levels to very high levels continuously. And what happens, I believe, and this is a hypothesis, is that in the receptor, the signal splits into two pathways. One is the neurological pathway, and the other is the matrix. So I suggest that the living matrix collects all the information from very subtle to very strong, including everything that goes into the nervous system, but also things that never make it to the nervous system. That's a suggestion. So the hypothesis is this receptor is where analog signals are converted. They're digitized. They're converted into digital signals. And here's an example. This is the pressure in the carotid sinus. As you increase the pressure, the spikes, the action potentials don't get bigger. Their frequency changes. So as the pressure goes up, so what is happening is the signal is digitized and it's converted from pressure into frequency. And then these signals go through the nervous system, and the nervous system knows about this, knows about what's going on. Second hypothesis. This input into the matrix gives rise to what's been traditionally referred to as the subconscious. I talked about this last year. So this is, for those who were here last year, this is nothing new. Another hypothesis, these inputs operate right down to very low levels, the quantum level. And the other hypothesis, the receptor is a filter that allows neurological perception to be manageable. In other words, if everything went into the nervous system, we would be overwhelmed. This is what Candace Pert is referring to when she says your body is your subconscious mind. This matrix, I suggest, the largest organ system in the body, is the subconscious. Huxley referred to the doors of perception. The body is a limiting device for consciousness. The conscious mind only holds small amounts of information at any given time. Jung said, psyche is not in the head or the brain. We always think that this is where our psyche and our mind is. Maybe not. Maybe it's all through the organism. Where does the matrix interact with the nervous system? Everywhere. The nervous system is one of the systems that is made from the matrix. So here's the idea that there's, yes, indeed, the standard pathway that we learn about in neuroscience, and there's another pathway which goes straight from a receptor to a muscle, and that is the living matrix. I'll skip this one. Last year, Hendrik, after I gave this talk, asked a question. Why digitize the signals? Why does the nervous system digitize the signals? Good question. Thank you for that, Hendrik. Some answers. To reduce an infinite input of energy and information to manageable proportions, to allow for digital information processing, and to give greater, better long-distance transmission quality through the nervous system. Digital systems reduce noise. I thought about this for a while, and then I remembered the Nobel Prize of 1970 to Bernard Katz. He was studying the motor end plate, the place where nerves interact with muscles. And there are vesicles in the motor end plate. They're synaptic vesicles. They contain acetylcholine. And there's a vesicle hypothesis that each vesicle contains an amount of transmitter that can trigger change in potential in the postsynaptic membrane. And if you record signals from this area, they look like this, and there are these little spikes which are called miniature end plate potentials. Katz got the Nobel Prize for this discovery. They are thought to represent quanta of information. Nobody knew what they're for. No function has ever been ascribed to the miniature end plate potentials. Here they are. Sometimes on a scale, they are 1 unit high, sometimes 2, sometimes 3, sometimes 4, and when they are close enough together, they depolarize the membrane and you get a muscle contraction. But these signals themselves do not produce muscle contractions. This is a possible explanation of what intention is all about, because there are electrical fields created in the brain before you move. And if you just think about moving, there are sets of potentials created in the brain that precede the action potential, and if there's no action potential, they're nonetheless there. Here they are. Could this be what intention is? Here are the signals in the brain that begin 2 seconds before a movement. Could these be telling the muscle what's coming? Well, this is an idea, and I'm going to leave you with this to think about. There are 2 subthreshold things going on in the organism. There are these subthreshold potentials at the sensory end that do not reach the nervous system, and there are these miniature end plate potentials at the other end, at the muscle end, that do not trigger a contraction. Think about these. Think about these. Let me know what you think. Remember, yella atama, movement is sensation in reverse, sensation is movement in reverse. Something for you to think about. And I thank you for your time and look forward to chatting with you during the meeting. And this is the best part of my talk.